Alright, for this problem we have a trailer, and this trailer consists of a deck. It's going to weigh 250 pounds, and the wheel and axle part of this is going to weigh 350 pounds. And what we can change is we're going to be able to move, weld the axle onto this trailer deck anywhere we want. So we want the tongue force, and the tongue force is the force that the trailer exerts on the trailer hitch of whatever's towing it. We want this force to be supporting it to be 50 pounds, where the rest of the weight is supported by the wheels. So we want to adjust D so that we get that 50-pound force. Obviously, the further we move this back, the more weight is going to be sitting on the front. The further we move it forward, it'll start to tilt the other direction. So we can draw out our free body diagram. This is going to be an extended body equilibrium problem. So we've got the deck of the trailer itself, and then at some point I'm going to draw in, basically this is the wheel and axle part of our trailer. And so we're going to have a couple forces acting on this. We've got the weight force of the deck, so that's 250 pounds. We've got the weight force of the axle, that's 350 pounds. We're going to have a normal force acting on these rear tires. And we're going to have the tongue weight, or the force of the trailer hitch supporting this. So this is we're going to call F sub T. And this we want to be equal to 50 pounds. And so we do know the weight of the trailer deck is going to be halfway along, or it's in the center of the trailer deck. So it's going to be halfway along, so this is going to be 6 feet from the front of the trailer to this 250-pound weight force. But what we don't know is D, the distance from the front of the trailer to this back axle. Alright, so now we have our free body diagram with all the forces and distances labeled that we know. We need to determine this distance D so that this is true over here. Alright, so the sum, for this we're going to use a moment equation. We're going to say the sum of moments, and the way I did this is I took the sum of moments about point B, and if it's in equilibrium, that needs to be true. Or the sum of moments about B needs to be equal to 0. Alright, so a couple things that are going on. We're going to have two forces that are going to exert a moment about point B. So this 50 pounds of the trailer hitch and the 250 pounds, the weight of the deck itself, is off-center. The normal force on the wheels and the weight of the wheels themselves aren't going to exert any moment about point B. So this, I guess I should try point A is the front, point B is wherever I put the axle. Alright, so the distance, so the force times distance, is going to be a negative moment from the tongue, the force at the tongue. So it's negative 50 pounds times D, I don't know this distance. And this 250-pound force is going to exert a positive moment, so it's going to counterclockwise rotation using my right-hand rule. It's going to be positive, so plus 250, and the distance between the wheels and this point is simply going to be D minus 6 feet. Alright, so the sum of those two moments needs to be equal to 0. We rearrange this a little bit. We're going to have negative 50D plus 250D minus, so negative 6 times 250. This gives me minus 1,500. Alright, so 200D is going to be equal to 1,500, or D is going to be equal to 7.5, and the units on this are going to be feet. And so with that, this looks like a fairly complicated problem, but using just one equation I can solve for the distance I need to get this 50-pound tongue weight there. Alright, so thank you for watching, and I hope to see you again.